Just a real quick finish up video. Remember we did the video NASA, Another One Bites the Dust, which shows definitively that what you're looking at with NASA is a fake image.
100% definitive, just like your 100% proofs that are always 100% crap.
Because in the NASA image, unlike this plane landing on the Earth, it shows that the entire Earth is moving at the same rate of speed.
Rate of speed? Oh, there's a new concept.
And I guess I should have put it that way because a lot of people didn't have the brains to really see that that's what it is.
Ah, don't be too hard on us, Mr. Thrive and Survive. We can only but aspire to your lofty levels of intellectual brilliance.
I pointed out that in this video here, you can tell the whole thing is not turning at the same rate. For example, what I mean by that is the close-up area appears to be moving towards the camera or towards the plane much faster than the background seems to be moving towards you. And of course, the people that want to just hold on to this ball theory came up with their own theory to try to hold on to their cognitive dissonance.
Not quite sure why I want to hold on to it, but talking of cognitive dissonance, how about bizarrely nonsensical notions of perspective that desperately try to get the sun on a flat earth low enough to pass as setting? Or water that always rises up to obscure distant objects while at the same time remaining flat? Or compass bearings of east and west that are also northeast and northwest on the equinox, etc., etc.
And again, this is going to be very quick. Let's show how they're wrong and we can get on with this. Here's what people don't understand. What they're saying is, look, if you look at it, things in the front move off the screen much faster than what these are coming in the back. Really? Can't you see? Let me see if I can get this past where I have these annotations here. Can't you see that this whole thing is moving together?
Oh yeah, I see that, Mr. Thrive and Survive. I think it might be because it's a bloody great big rock.
Compare that to what you just saw. The whole thing is moving as one unit. Now there is a reason why the things in the front are moving faster than the back, other than the fact that this whole thing is moving together. I should have put it this way the first time. And guys, this is why my videos tend to be long, because when I leave out any little detail like this is the problem you run into, because people, I'm telling you, they don't have the deepness of the thought pattern to be able to come up with logic.
Ah, logic, yeah, I remember that.
Logical answers.
In other words, convoluted nonsense to fit your narrative.
So, let's go ahead and point out something. We're going to be looking at this spot right here and this spot right here. These two lit up areas. We should be talking about why the clouds, with the sun not being there, are lit up on the top. But we'll skip that for now. Starlight, huh? And here's another thing too. The stars in the back rise up. I don't understand that either.
No, Mr. Thrive and Survive, you wouldn't understand that, even though you did a whole video demonstrating how when you dip down things in the background rise up. Don't you remember?
But that's, I guess, a perspective thing. What people don't understand is the distance between these two is going to change as it gets closer.
I think you'll find most people actually do understand that.
That's how perspective works. It doesn't mean that just because this falls off faster or appears to move faster in the front than in the back that it is.
Oh, right, but somehow it is here though.
Because as you can see, any body with a brain that functions normally, even with my perspective, can look at this and say it's all moving uniformly together, unlike the airplane.
And now we're about to be treated to a demonstration by this logical heavyweight that this is precisely not the case.
If this was Baltimore and this is DC, which is 40 miles apart.
Absolutely no sense of scale and no surprise there either.
And it appears 40 miles apart here. When it gets closer, as you're going to see here, the distance between them appears to increase. Why is that? Well, that's just a thing of perspective. So by the time they get here to where DC, let's say, is going off the screen, look at the distance between the two. That explains why things in the front are going off the screen faster than in the back. But it doesn't take a genius at all, just takes somebody with common sense, to look at this and realize that it's all moving at the same rate.
Ah, of course, flat earth logic. Even though you've just demonstrated that the top half of the image is moving much more slowly than the bottom, it's nevertheless all moving at the same rate.
All moving at the same rate. Now go back and look at that aircraft flying into London. It is not all coming at the same rate. Okay, here's what I did. I put them side by side so you can watch them here. I sped up one and slowed down the other. You can see the one on the left. It's all moving at the same rate. The one on the right, you see how the background isn't moving nearly as fast as the foreground.
Oh yeah, I can do that as well. Here's an animation I made using Bryce. It's a camera flying around the globe at 2 different heights. Here it is high up, and here it is flying low down. Looks a bit like yours, doesn't it, Mr. Thrive and Survive? Do you feel like a Burke yet? Nah, of course you don't.